Hello and welcome to Samsung. In this video, I'm going to talk about the concept of access point groups. This is one of the most important concepts to understand because almost every deployment that is done with the Samsung wireless LAN solutions, it is recommended that an AP group be created. So let's get started. So as you can see here, I'm logged into one of my controllers and I go into configuration AP group. So the concept of AP group is basically taking a bunch of access points and applying a policy on those set of access points. So to give you an example, consider an enterprise scenario where you have multiple buildings, you have multiple floors. There might be a need to propagate or broadcast a lot of SSIDs, and that's actually not a good idea because SSIDs, the more SSIDs you start broadcasting on APs, it takes up a lot of airtime, and not just airtime but RF resources. So it increases the channel utilization, and there's a whole science to when you go and add like start going above like five or more SSIDs or six or more SSIDs, it adds to the overhead. So that's actually not a good idea. So access point groups make it very flexible for you, allow for a flexible architecture where you can group the access points on each floor and and apply policies per se, both on the RF side as well as on the wireless LAN side, only to that group of access point. So I may have, multiple floors, and I don't want to, I may have a floor which is just employees, and that these might be accounting, sales, and all they need is just a corporate SSID to connect to if they're connecting wirelessly. And then I may have a floor dedicated to a lab, which might need a lot more SSIDs for testing purposes. So not just the employee SSID, but they might need, certain lab SSIDs that only need internet access and things along that line. So AP groups allow us to do that. It is my recommendation that whenever a deployment is done, you even if it's just like one establishment, one floor, you still group the APs. It's always a good idea to group the APs. Now what happens is once the access points come up, by default whenever an access point is plugged in and it registers on the controller, it becomes part of the default group. And you can see like the moment I plug in an access point, it becomes part of the default group. And then any wireless LAN that is created, any SSID that is created that that you've learned how to create in the previous videos, it becomes part of the default group. So you want to get the APs out of the default group and put them in the appropriate groups as soon as possible. So let's go ahead and see how we do that. So to create an access point group, you go into configuration, AP groups, come here, add an AP group, provide a group a name. So we'll say floor 1. Remote AP group is a concept that I want to talk about once we have a much better understanding of local bridging. So let's check this for now. So all right, so once that is done, you can see that right now there are no access points in my group. So floor 1 with the remote is checked. There is no AP count. There is no WLAN count. And it does allow me to check it, and I can actually delete it. The moment I start adding like APs in this, so the part of as part of the group, I'm going to add access points. I'm going to add the SSIDs that are associated with that access point. So the moment I start doing that, it will not allow me to delete it. So if I want to delete any of the existing groups, I have to make sure that I remove all the access points and remove all the wireless LAN from it, and that might and that would allow me to delete the floor. So now that being said, let's go in here. So here you can provide a description. So this is building 1 floor 1, or it could be anything there. So You check this, so it's a AP config, override AP config. You can check this, and this is the override AP config. This discovery type value is associated to a redundancy. So, for instance, if you are, if you have multiple controllers and they are behaving in an active fashion where you have a set of offices registered on one controller and then other set of offices registered on the other controller, and they're both backing each other up. This is where you're going to come in and tell the group of access points which controller to go on to. So you select APC referral, and then you select who's your primary controller and who's your secondary controller if you have any. So I don't have any in this, so this is going to be how it is. So having the discovery type set to APC referral, you can basically tell a group of APs that your primary controller is A and your secondary controller is B. And this could be a group of APs in the same building. So floor one, you can say, your primary controller is the controller in a location A, and your secondary controller is in the location B. Versus another building, you might have the same floor. You say, building one, floor one, primary is A, secondary is B. Building two, floor one, primary is B, secondary is A. That's how you can load balance across the controllers. This is, of course, assuming you have a huge multi-site deployment. The next step in the process, obviously, is to add the access points in the group. So what you do is you go ahead and select all the access points and all the APs that are listed here, and you add them to the group. As simple as that. The question now comes is, if you have access points that are, can access points be part of multiple groups? And the answer is no, they can only be part of one group. So the next step is to add the wireless LAN. So now again, you have a group of access points, and you can basically have multiple SSIDs, obviously, broadcasting across that group. Now, the good news is that you can have SSIDs that are tunneling back, and at the same time, you can have SSIDs that are locally bridging as part of the same group. So again, the architecture is very flexible. Now, in this case, for instance, I select the voice SSID, which is tunneling back to the controller, and you have the guest SSID, which is locally bridging, for instance, and you say apply. Now, the thing in this case is this doesn't apply to so in case of wireless LANs, they can be part of multiple groups because that's irrespective of the group. So you can have group one, AP group one with the same SSIDs and group two with the same SSIDs. So it doesn't matter. The next setting is the radio setting. So again, you can see that now on a per group basis, I'm able to even go in and apply these radio settings also. So you now have like your own profile per that group. So you can basically say that this group of access points, I want them to be transmitting at X power. So if you want to fix the power, you can do that. One of the amazing things about this is that it even allows you to select the bandwidth for that group of access points. Now, this is amazing. So, you may have a group of access points that are catering to a conference room, and typically in corporate environments, we tend to, based on the design, we tend to keep on the 5 megahertz. On the 5 gigahertz, we tend to keep the channel bandwidth either at 20 or at best 40, because that allows us to get multiple channels. But we normally never select 80 megahertz bands. We only select it in areas where there is high density, and we know that we can split the channels equally. So this could be a group of access points in an auditorium, within the same establishment, and it could be about two or three access points just catering to that auditorium. So in that case, I can select the bandwidth 80 megahertz. Versus if it's a regular floor or a work floor, I can go in and group those access points, and I can say the bandwidth is 20 megahertz. So this is extremely flexible. Once that is done, you go into the 802.11 BGN. Again, you can select those same values here. In case of ABGN, you don't, the bandwidth is on, you have like 20 megahertz and then 40 megahertz for 802.11n. So, okay, let's talk about remote AP group for a minute here. So this is a very important concept. So consider a scenario where, again, the controller is in the cloud somewhere and you have remote branch offices. Or have, that is not just the only scenario. It could be where you have the controller and you are locally switching the user data traffic on an SSID, and you actually want once the AP locally switches that traffic to go into a particular VLAN, which the customer might have. So let's look at an example here. So I have the controller here, and I may have multiple sites, and each site has a switch and a router, and they want to have multiple SSIDs. A much better or a deeper dive would give us something like this. So this is a customer side configuration. They have a firewall gateway. The controller is somewhere in the cloud, and they have a DHCP server and stuff. And you can see that they still have the need to do multiple VLANs on the SSID. So you have the corporate SSID, you have the voice, you have the guest, and the WAPs are in their own SSID, and the DHCP server and the router is capable of doing VLANs as well as the switch. So at that point, you're going to group these access points, WAP1, WAP2, and WAP3 into one AP group. Assign them all their SSIDs, and then you have to make sure that the corporate SSID is part of VLAN 5, the voice SSID is part of VLAN 50, the guest SSID is part of VLAN 25. Meaning, when someone connects on either of these SSIDs, the WAP layer 2 switches, right? So it tags VLAN 50, VLAN 25, and VLAN 150 to the switch. So the switch is configured. You can see uplink to the firewall, the switch port mode trunk, and so the switch is now configured to handle these tag traffic. So obviously there's a lot more configuration there. But for us to specify that a locally bridged WLAN has to switch the traffic on a particular VLAN, we need to come here into the remote AP group. That's where you select remote AP group if you know very well that that's going to be the case. You come into remote AP group, you come into ACL profile, and then the first thing you do is you select tunnel forwarding and local bridge forwarding, say apply. And then you select your locally bridged VLAN. So let's say guest SSID. I want to make sure that, so just a note here, when you select the WLAN here, this is the profile name. This is not the SSID. So customer one underscore guest is the profile name. So if we come here in the WLAN, you can see that profile name is customer one underscore guest. The SSID is guest. So whenever you're creating a WLAN, make sure that you put the profile name appropriately. You can change the SSID, but your profile always remains the same. All right. So you come to the AP group again. Let's go to floor one, remote AP group, ACL profile, and then you have WLAN customer guest, and I say customer guest SSID is, I don't know, 50. Oh, sorry, the VLAN is 50. The moment I do that, whenever I make a change like this, you always, and if the APs are online, you may want to select send to APs so that it immediately sends that configuration over to the access points. And the access points, start, the process of, tagging this WLAN. So that's the whole idea. I hope that concept is a little clear. It takes a little while to get it, but once you get it, it's such a flexible architecture. It allows you to do quite a lot of things. Okay, so the next step is going into the advanced setting. and making sure that we enable a few things. So you override the AP config here, make sure that the APs are, the telnet and SSH is enabled. By default, we use 50,023 and 22. So if you want to change that, enable console. It's always a good idea to do that. Another thing I prefer to do is override AP config, especially in case of the PoE type when it comes to 400 series. So if you have 403s and 412s, they do PoE plus. Now at times, auto negotiation with certain switches doesn't work. They like to what I have seen with Cisco especially is that the setting here has to be forced to say PoE plus. PoE type is 2.380, and you don't say auto. Normally, you know some people prefer to keep it at auto, but based on my experience, PoE type should be 802.380. So we force the 80 connection, and you want to always make sure that the WAPs have negotiated 802.380. And the way to do that would be to go into the monitor access points, all APs. So for instance, let's say, you select this access point here. You can come into the details of the access point, and there would be a place where it would say whether it's a PoE. So power type here, advanced, it says PoE 802. So someone here has actually plugged it into the PoE plus switch. So you always want to make sure that the 400 series negotiate PoE plus if your switch supports PoE plus. All right, so that being said, the AP group configuration is now done for floor one. Again, coming back, if you want to delete the AP group or do anything with it, you will have to remove all the access points from here, from the group, remove all the WLANs from the group, and then go ahead and delete it. I hope this was helpful, and we'll do another nugget, and look forward to seeing you there. Thank you.